Hey there, you're tuned to the Portable Crows channel, and today we're going to be going over a whole lot of different things with this radio. We're going to look at the power supply, we're going to do a couple checks with that. We're also going to look at some components, such as some suggested capacitors that people recommend replacing. We're going to look at some resistors, and we're going to look at the two relays. I also want to do a receive check and just try to find a strong signal and see how well the audio sounds before we actually start changing any components in here. And we're also hopefully going to try to get the transmit side to work. So lots to go over. Stay tuned. So one good check, probably should have done this before I turned this on for the first time, is to check the resistance of our DC pins. So I have our multimeter set to ohms. The power cord is unplugged, the radio is off. I'm going to put this lead here to the chassis, and then we'll check the DC pins. So here's the DC negative 100 pin. So that looks like it's a good. And just making sure it's really not shorted. I didn't understand fully of what we're checking for. I just did some more research, and I think this is to see if the resistance kind of wanders, to make sure the power supply capacitors aren't like shorted or damaged. So we're just trying to see if the resistance kind of wanders a little bit. So looks fine. And the 600 volt. So I'm assuming those are okay. So I want to look at the voltages, the DC voltages, the negative 100, the plus 160 volt, and this plus 600 volt, and the 13.8 volt DC, or is that 13.5 volt? 13.5 volt DC leads here, and just to see, how healthy our power supply is. I want to see if we're kind of in spec. I already had turned this radio on. Nothing's blown up or anything, but doing some more research. Some people do, leave this lead on the chassis and then take your hot lead and check the DC pins and just see if the resistance kind of wanders. If you have your multimeter set to ohms, and I think that's just to kind of see if the capacitors aren't shorted and that they're functional. But I've already turned that on, so what I'm going to do is check for voltage. I got the cord's not even hooked up, it's powered off. But since I'm not very comfortable with high voltage, I'm just going to use one of these little clips, and I'll just clip it on there one way or the other, like so. And then I will turn the radio on, measure it, and then I'm going to turn the radio off, move the other lead, etc., and just take a nice, safe, slow approach to this. If you do have a lot of experience with high voltage, you do your thing. I don't, and I don't want to be near a lot of high voltage. I'm just not comfortable with that yet. So I'm going to be hands off for this test. So it's a nice, safe alternative. So I'm going to get the cord all plugged in, and we'll do some measurements. The multimeter is set to DC voltage. I've got the lead, black lead connected to the chassis, red lead connected to negative 100 volts. The radio is now plugged into the power. I got the heater switch off. All I'm going to do is turn the power switch on, and we'll see what our negative 100 voltage lead shows us. All right, so negative 147. And if I recall correctly, I heard somewhere say that on AC mains, our DC voltages will read a little bit higher. So I'm going to assume that's okay. I'm more looking into something that's really low or way, way, way out of spec. And this could be, I don't know, I got to read the manual. But there we have it. So I'm going to turn the radio off. And we'll move to the next lead. If I can find the switch. And so voltage dropping, I'm assuming that's because the capacitors are still having a little bit of a charge and that they are just draining. All right, so let's go to the plus 160 volt lead, and I'm going to turn the radio on. All right, 181.6 volts. Let's turn the radio off. And now the capacitors look like they're just discharging. So good little reminder that even though the radio is off, it can still shock you potentially. All right, so let's go to the 600 volt one now. Whoops. All right, I'll turn the radio back on. Oh, that's the AC one. I put it on the AC one on accident. There we go, 600 volt. All right, 748 volts. Spicy. Okay, turn the radio off. There we go, discharging some of our capacitors. So good reminder that this radio is still hot for a couple minutes or so after the power is off. So keep that in mind if you're trying to, turn it on, test something, then turn it off real quick and unplug it and then get right into it, that you might want to wait a little while and or check the voltages because there's still 140 volts on there. All right, so last one I want to check is the 13.5 volt DC check there. Turn the radio back on. 14.6. It's not bad. So I will review in the manual just to see what the expected range is for those voltages. But I'm just trying to do some initial checks here to kind of prioritize where the next place for me to focus will be. So looks initially that our power supply is fine. Again, I'll review those values in the manual, but I'm thinking that the capacitors for our power supply are okay for now, so probably don't need immediate replacement. Definitely probably recommend replacing them eventually, but there we have it. So on to the next checks. So there's 3 other capacitors that I want to check that are under this plate, under this trimmer board, and they're for the driver. There's 2 driver coupling capacitors and a neutralization capacitor from my understanding. So I wanted to just check the resistance on those, see if they're still good. I don't have any replacement parts for those yet, so I'm not going to replace them. but I want to just check them out. As well as those 3 capacitors, there's 2 screen grid resistors that supposedly can go bad. So we're going to check those out. So I got to take this all off, and we'll go from there. But it looks like there's a handful of screws, and if I recall, I had to take these 2 nuts off to get under here to clean it. So that's what I'm going to be doing. So I got all the screws out. I did not need to take off these nuts here. Not sure what they're holding. It's probably for part of the case. So let me get a better angle to show you what we're working with. Oh, before, I'm going to take this trimmer board off. There's 2 screws holding that up. Alright, so the trimmer board's up out of the way. You know, I said previously that there were 3 capacitors to look under here. And this is the first time I actually pulled this board up. So I pulled it up, cleaned it out with some isopropyl alcohol and lightly hit it with the heat gun to evaporate it. And so I got it all cleaned, and then I was inspecting from the videos that I've been watching. They were mentioning 1,000 picofarad capacitor in here, and also looking at the video, it was all wired up to this band switch, gang switch thing there, and mine has there's 0 connections on there. And I was looking in the schematic, and it looks like this gang switch, this big old gang switch here, that goes from here all the way down. It's labeled A, so like switch 1, A, B, C, D, E, F, G, H, I, and I could not find the I at all. Maybe because there was no connections, but I'll have to look a bit more closer later. And then J, K, and L. So, I guess there's only 2 capacitors in here to check for now. So maybe the video I was watching was for like upgrade or mods or something, but for now we'll just check the 2 capacitors. And the first capacitor we'll check will be this one, which I believe is C13, and that's for the driver coupling capacitor. And then right down here, if you can see it, it looks similar to that one, another brown box. That is I believe C125, the neutralization capacitor. So I'm just going to check those. And then for the resistors that we want to look at, we want to check this resistor and this resistor. So I'm going to measure these resistors first. If I can get my hands in there. We're going to measure the 18 kilo ohm one first. Not really sure why it's like slowly creeping up. I would expected it not to do that, but here it is. So a little low, but that might be in spec with this resistor. I'm not sure what the tolerance is on this one, but 16.44. So the other resistor is a 5.1 kilo ohm. Is it not working? It is tied to this. Maybe we have a bad resistor. Oh, there we go. Alright, 5 point... Oh, it's still going. So we'll say 6.3 kiloohms. Okay, so the next thing we'll do is we'll measure those capacitors. Okay, so since we're going to be looking at capacitors first, I'm going to change the multimeter to DC voltage. And I just want to see if there's any voltage on this capacitor. So here's where one lead goes. Here's where the other lead goes. Looks like we're okay. And then for the other capacitor, is there voltage on that one? Looks okay. I don't have a discharge tool, so that's what I was looking for. Okay, so I'm going to go back to ohms. I don't have a way to measure capacitance at the moment, so we're just going to see if this is shorted or not. So what do we get? So this capacitor seems to be O, right? It's climbing up. Yeah, so I think that capacitor is good, but we'll still replace it. That's what everyone seems to recommend, is replacing these capacitors anyway. The fresh set, so we will, but just really want to see if they're okay first. And then when they're out, we can measure them a little bit better. And that seems to be all right. So those are the components that we wanted to check in there. The next ones that we want to look at, since we didn't have any drive that we saw in an earlier video, I want to look inside the high voltage cage and measure some resistors in there, and I believe one capacitor. So I'm going to button this all back up for now, and then we'll go measure that. Alright, so I got it flipped around. We're in the high voltage cage. And again, anytime I'm working on this, it's unplugged, power's off. I'm assuming you're doing the same if you're watching. Be smart. So what I wanted to look at was mostly this capacitor right here, which I believe is the neutralization capacitor. And just going to put my multimeter on, it's just on DC voltage right now. I don't have a way to discharge these, but I'm assuming they're empty because it's been off for a while. I'm at, and it's going down 70 millivolts, so I think we're good. So I'm going to go back to ohms on the multimeter. I just want to see if this is good. Looks like it. I'm getting a 0L. Let's reset it. 0.L. So that's what we're getting when I look at that. So I think this is good still. This capacitor here, I'm just going to check it while we're here right now. So I got it back on DC volts just to see. 28 millivolts, we're good. Go back to ohms. And what do we get? Yep, resistance is good. It's climbing. All right, so the main reason I wanted to get in here, besides checking for this particular capacitor, was I want to find the bias resistor, or I guess also known as the grid resistor, which is a 100 ohm resistor. Some of my Googling says to check that if you're not getting any power out, but it looks like it's back in the area that we were just at, but on a different side. So I'm going to close the cage up, flip the radio back over, and open up that back panel again so I can get underneath here, because it looks like it's way down there on the other side and I can't get to it. All right, the transceivers turned back around. Got that one panel off that we were just under. Here's that trim board that we had out. And the only 100 ohm resistor I see is this one here, which is the brown, black, brown, silver striped one, which is 100 ohm plus or minus 10% resistor. And this is the bias resistor, aka grid resistor, that Google told me to look at if I was not getting any transmit out power. And since we weren't in an earlier video, I wanted to check this out. So measuring ohms here, we are at 150 ohms, so that is definitely out of spec. So hopefully that is our issue for not getting transmission power. So we'll definitely replace that later. But one more check that I want to do now is just hook up a random wire antenna that I have laying about. We won't transmit on it, and I just want to see how well receive sounds. I do know that there are some capacitors that are cracked that will need to be replaced. I noticed one of the Mylar capacitors, similar to looking like that, was cracked on the board that has the filter, the single sideband filter on it. So that's on my list of things to replace, but I just wanted to really see how well receive sounded and go from there. So there we have it. We do get receive. It is a little kind of muddled or distorted a little bit, but again, there's broken capacitors that I've noticed that I've recently cracked that I missed during the cleaning that I need to get replaced. Using an indoor antenna probably doesn't help, but receive is working. And hopefully after we replace some of the capacitors on like the filtering board and the other boards that I need to replace caps on, that will improve, as well as getting this aligned. So receive works. Now I'm just going to go ahead and try, I'll hook up a dummy load in the watt meter, a different watt meter this time, and we'll just test and see if transmission works and go from there. I don't think it will, since we did measure those out of spec resistors, but we're going to do one more check. Let's get the radio turned on. It's been warmed up already from all the receiving tests. So I'm going to go ahead and turn the heaters on. Let those warm up. And I'm going to turn this on into CW mode. And we'll stay on the 20 meter band. I'm going to put the plate to 20, the loading to 2. I'm going to put the carrier down, mic gain down for the heck of it, because why not? 20 meter. Clarifiers off. We're on PTT, noise blinkers off, attenuators off, our little tuning tones are off on INT, and let's go up to IC. And so we'll let that warm up for a bit, and I'm going to be testing out this old Royce model 2-098 watt meter, SWR meter, hooked up to dummy load. And I'm hoping the power works. If not, again, we saw some components that we want to replace. But I just realized when I was doing some other tests earlier in the week, the coax cable that I was using with the other watt meter in an earlier video, this cable here is actually no good. I did a continuity test, and ground and the center pin are grounded, so or shorted. So I wonder if that may have had a part. So this cable's no good. I got a different cable hooked up now, and we'll see what happens here. Well, the tube should be warmed up well enough now. And we got the carrier mic gain. I'm pretty sure this is the carrier. So that's all the way down. We're in CW mode. I'm going to flip the Mach switch open. We'll see if we hear a tone. And then we'll also see if we get any power out. So here we go. No tone. And no power out. Let's crank this up. We'll just do halfway. We'll put the mic gain up halfway. And I'm switching the mic gain up and down in case I'm reading this front panel wrong. But here we go. No power out. Okay. I'm kind of surprised I don't hear a tone either, being in CW mode. I might go get a key and, oh, you know what? I think we had that box for Morse code. I think we had to put it in Vox when we hook a key up. So I'm going to go grab a straight key real quick and then just see if that makes any difference. So go check that out. So I went and hooked up a straight key for this. I put it in Vox mode. If you leave it in push to talk and you key the key, it'll send out a tone, but you won't hear the relay click. So if you put it in Vox mode, get a tone, and you can also hear that relay click. But we got no power out. The carrier again, it's halfway. So, and even with the power switch, the power output meter, there's nothing on there. So that was our last transmission test until we actually go and replace some components. So I got the radio off again. I checked the voltage. The capacitors have been discharged. And what I want to do is take this relay out and that relay out and get those cleaned. I never did take those ones out and deoxidize them. Again, in like part one, cleaning this, I did not have any deoxit or any electrical contact cleaner. So I used isopropyl alcohol on all the electrical contacts. But I'm going to use some automotive electrical cleaner that I have for those relays. So hopefully getting those cleaned up will resolve our transmit issue of having no output power. I was looking at the service manual and it talked about being possibly relay 2, which is the one in here. So the relay's out now. It was really quick. This white paint marker indicates that the relay is installed with that white marker closer to this wall. So it'll just go in like this, put it in there. And to safely get it out, I just used some needle nose pliers and I put some electrical tape on it so I didn't scuff the relay up, but it was not stuck in at all. It was really easy. And the contacts, I mean, they look okay. Maybe a little oxidized. The socket though looks really dirty, so that I need to spray some electrical contact cleaner in there to clean it. But first, I want to test this relay and see if it's actually any good. So let's do that. Well, hopefully that's easy to see. So I was using the Fox Tango website, which has a lot of useful information on restoring the FT-101, and I found the specification sheet for this, and determined, the pins. So let's see. Here we go. We can see pins 1, 3, 4, 6, 7, 9, 10, 11. So they're marked on there. It's really hard to see though with this lighting. But this bottom where the white paint marker is the coil, and it says that it has a resistance for the 12 volt model, which is this one. You can see DC 12 volt, and it even gives you the ohms at the bottom, 125 ohms. And the specification sheet said it's plus or minus 15%. So I want to check the coil first. So put it on ohms, and then we'll Measure that, which gives us 122 ohms. Okay, so then the next thing I want to do is see if the switches are good, the normally closed and normally open. So the common pins are 7 and 9, which are the ones right next to the relay. So there's the common pin. We'll check the normally closed first, which is the one at the top. So we get 0 ohms, which is good, very good. And then for the normally open, should get in just like that, 0.L. I'm not sure. I need to look up what that term means. I'm still new, as you can tell. So let's check the other side. So common to normally closed should give us 0. Good. And then common to the normally closed, 0.L. Okay. So relay is good. The next little check, I just got a 9-volt battery. And I'm just going to connect it to the coil end, the 2 coil ends. And should we at least hear it click if it's working? Yeah, it's working. So relay is good shape, so that's good to hear. So I think we just need to clean it. I'm not going to bother opening this since, I mean, it looks really clean in there. I hate to bust it if I do open it. So I'm just going to clean the outside pins and the socket that I went into, and if we still don't get any success, then I'll take this apart and open it and clean it, but I don't want to risk breaking it, so that's what I'll be doing. You know what I'm gonna do? We're gonna just test this out right now to make sure I don't have to open it up and clean it. So we're gonna hook up the common to the normally closed. I can juggle here. Okay, we got 0 ohms. Let's hook up the battery. Now it's saying 0L. So that's a good indicator that it is working internally for at least that part. So we're back to 0. So let's go to the normally closed, which is really hard with the bum thumb here. Thumbs are important, don't hurt them. Come on now, work fingers. Okay, 0L. So we should get a resistance of 0 ohms. When we turn this on, there we go. So I know that side works. Let's do the other side. So common, normally closed. It's saying, should say 0. Come on. Okay, turn this on. Should tell us. Should go to 0L. If I can. There we go. And then let's do the common to normally open, which should go to from the OL to 0. There we go. So I'm not going to clean the inside. That's my test. Good enough. I will clean the outside though. I will clean these pins and the socket. So here's the relay, the RL1 relay. A lot of pins here, and I could not find a data sheet on this one. I didn't look very hard. I was just kind of browsing on the Fox Tango website. So there might be one out there, but these pins look good. We know during our test we've been hearing this relay click. I have not been hearing the relay in there click. So I'm gonna assume this one's okay, but I am going to, just use the electrical contact cleaner on the outside of these pins and in the socket, but I'm not gonna open this up. It looks pretty good. Looks nice and clean. Um, so yeah, here it is. All right, I'm gonna go clean them now. Oh, and for taking that out, this wire in here, if I can get this little wire thing, I was able to just carefully pull it all the way to the side, and it came off, and was able to pop the relay out. So it was really tricky though. I did take a few minutes to get that out, and then I just used these to carefully kind of wiggle it and popped it right out. But yeah, putting it back in, it's pretty obvious. All the pins, it's well mapped to the socket, so there's no worry of getting that wrong. This is electrical contact cleaner I used. I just got it at an automotive store years ago. Pretty full. Gave that a try, and what I ended up doing was I squirted it into the socket of each of the relays, gave it a few minutes to dry, and then I hit it again, and now I'm just letting it dry. And then for the relays, I just took a sheet of lined notebook paper and folded it and squirted some of this cleaner on it. And then I just ran it through these contacts. And I don't know if you can tell, but it's pretty nice and shiny and clean. And I just ran it through a few times, and some gray, residue came off on the paper. So that was showing that it was working. And again, I did not open this. I just cleaned the outside connectors. This one had probably the biggest difference. I don't know if you can tell on the video, but it was pretty gray, ashy, cloudy before, and a lot of residue came off. So hopefully this was the thing that we need to do to get transmission to work. So I'm going to let this air dry for a few more minutes, and then put these back in, and then probably wait another day before I turn this back on, just to make sure it's all good and dry. This stuff says it's quick drying, and I believe it. I mean, this stuff evaporated pretty fast, but I'm going to wait a little while, just in case. I have the radio on now. The two relays are put back in. I got the high voltage cage put back together. I'm just letting it warm up a little bit, and then I'll turn the heaters on, wait for a little bit, and then we'll test to see if we have transmission after cleaning those two relays. I'm going to turn the heater on now. It's been over a minute or so. I got the straight key in. I'm in CW mode. I'm going to put it in box. I have the carrier all the way down, but let's just see over here if this meter moves at all. Nothing there. I'm going to turn the carrier up and stuff, and mic gain up just a little bit. I'm not sure which knob it is. I'll just move it up there. See if that works. Oh, we got power out. We got power out now. Heck yeah. Not a whole lot. I'm just going to do one more test. Just at the middle mark now. And then that'll be it. Look at that. Not a whole lot of power. That's okay. We're actually getting out now at least. So my guess, it was the relay 2 back there in the cage. It was just too dirty. But we do have some components that are out of spec that we do need to change. The radio has not been aligned yet. I haven't even tuned this up correctly for like dipping the plate and stuff, so I don't want to transmit too much and be hard on the tubes. I just wanted to see if we actually can get transmission to work, and it does. So awesome. That makes me excited. So the next step now is I want to go ahead and measure some more of the resistors near that 100 ohm resistor that we found that was bad. I want to go see if any other ones are bad, and I want to order some parts. And then once I get all the parts, I will swap those, and then we'll start getting things a little bit more aligned, I think. But making good progress. Well, that concludes today's video of doing all of our different checks and getting the transmitter side on this radio working. I've got some parts on the way, The next video, we'll start actually changing some components. So stay tuned for that one. Anyway, signing off from the Portable Crows channel. Thanks for watching. 73.
I'm now a radio man. You can bet your boots he knows his stuff.